We'll continue our discussion about counting by adding in some information about something called combinations. Okay, in class we may have done this problem. There are 5 runners in a race. In how many ways can they finish the race? And that would be, well, any one of the 5 could come in first, any one of the 4, 3, 2, 1, which would be 5 factorial. If the problem changes and says there are 5 runners in a race, in how many ways can we determine the first, second, and third place? Now we only care about who came in first, any one of the 5, who came in second, any one of the remaining 4, who came in third, any one of the remaining 3. What if the question is there are 5 runners in a race? If the first 3 to cross the finish line get medals, how many combinations of winners are possible? Well, any one of the 5 could come in first. Any one of the 4 could come in next. Any one of the remaining 3 could come in third. But if we're just talking about combinations of winners, and we don't actually care who was the first place winner separate from the second, separate from the third, then if it's Mary wins and then Betty comes in second and Alice comes in third, that would give us the same 3 people getting medals if Betty came in first and Mary came in second and Alice came in third, poor Alice. Or maybe Alice came in first and Betty came in second and Mary came in third. So we've got, and I could continue to do this until I exhausted all the possibilities. But these are the combinations that all look the same. Now, granted, winning second place and third place are totally different things. But if we just want to talk about, we're taking a photograph of the 3 winners, who might they be? It could be that there's different ways that show the same 3 people. So what happens is we end up dividing by the ways in which we could actually place those 3 people in those 3 spots. So 3, 2, 1. So with a combination, if we don't care about the order of things, we initially care about the order, and then we divide to get rid of the fact that a lot of these are repeats. Okay. In how many ways can we choose 2 student leaders from a class of 8 students? Well, any one of the 8 students could have been chosen first, and then any one of the remaining 7. However, Alice and Betty, as our student leaders, are the same as Betty and Alice as our student leaders. Student leader doesn't determine an order, it just says who are they. So I'm going to divide by either one of them could have been chosen first, and then whoever was next was chosen next. This is small enough a problem that I can do this. So 2 times 1 is 2, so that's 4, so that makes 28. In how many ways can we choose 3 student leaders from a class of 8? Well, we could choose any one of the 8 first, any one of the 7 next, and any one of the 6 third. However, if it's Alice and Betty and Carol, it could be Alice and then Carol and then Betty. It could be Betty and Alice and Carol. It could be Betty and Carol and Alice. It could be Carol, Alice, and Betty. It could be Carol, Betty, and Alice. Those are the 6 that would all put the same 3 people in our leadership spot. So that was any one of the 3 could have been chosen first. Any one of the remaining 2 times 1, 3 times 2 times 1 is 6. So there are only 56 ways that that could happen. In how many ways can we choose 3 ingredients for an omelet if there are 10 possible ingredients and you're not going to double any of the ingredients? Well, 10, 9, 8. But when you say to the chef, make me an omelet with onions, peppers, and cheese, will you be upset if the chef throws the peppers in first and then the cheese and then the onions? Is that a different omelet? Not really. If the chef throws in the onions and then the cheese and then the peppers and the onions and the cheese. Oh, maybe he shows them the cheese first and then the peppers and then the onions. or the cheese and then the onions and then the peppers. That's probably for a cop. So we're going to divide by 3, 2, 1. Any one of the three could have been thrown in first. Let's see, that's 3 and that's 4. So that's 120 ways. How many ways can we choose 5 ingredients for an omelet if there are 10 possible ingredients and no doubles? Well, any one of the 10, 9, 8, 7, 6, right? That's 5 ingredients. But again, the order in which the chef puts them in there doesn't matter. So he could throw in any one of the 5, 4, 3, 2, 1. Let's see, 3, 2, 1 is 6. 4 with 8 is 2. 5 with 10 is 2. So we have 36 times 7, 42. Regroup the 4, 252. I think that's right, but I'd probably check it on a calculator. At 31 flavors ice cream parlor, you decide to have a 2-scoop sundae. How many combinations are possible? Well, any one of the 31 times any one of the 30. But if they're coming in a bowl, not a cone, the order in which they're on there doesn't matter. So 2 times 1. So that would be 15 times 31. So that would be 465. 31 flavors ice cream parlor, you decide to have a 4-scoop sundae. So that would be any one of the 31. Well, as long as you're not doubling. I probably should have written that in the question. You're not going to have like 2 scoops of chocolate. 30, 29, 28. And they could put in any one of the 4, 3, 2, 1. I'm not going to do that. But on your calculator, if you're going to do this, you can put in the multiplication. I would put the division in a parenthesis, or you could just call this 4 factorial. Yeah? Okay, how many ways can you write the answers to the first 3 questions on a 10-question matching test? 10-question matching test. Let's see, there are 10 choices, and then you make one of the choices, and there are only 9, and then there are only 8. Does the order matter? Like if the first 3 answers were A, F, I, would it be different if you wrote I, F, A? Yes, so that actually is done. That's done. Order does matter there. How about choosing 3 morning classes? Choosing 3 morning classes. Not really, because if there are, let's say, 40 classes to choose from, 40, 39, 38, yeah, but just choosing them. Now, scheduling 3 morning classes, if there were 40, that does matter. And some of you know that. Like, you probably don't want to have 2 math classes back to back, or maybe you do, but the order of that does matter. So we do want to listen to, in the real world, does it seem like the order of this matters? Then don't divide. If the order doesn't matter, if it's making repeats, then we do divide.